In this example, we want to go a little bit further with our position and velocity functions, as well as our acceleration function. So for this example, we have a small rocket that is given into flight by the function s sub t is equal to negative 16t squared plus 80t plus 96. And of course, we're only interested in time that's positive or when time is greater than 0. So remember that this function here, this s sub t, is going to be our position function. So I'm going to write that down here. We have our position function, or height, and it's given by negative 16t squared plus 80t plus 96. Now the first question says, determine the velocity of the rocket at time t. Determine the velocity at time t. Basically, that just tells me that I want to know what is the function that represents the velocity at time t. So for that one, we're looking at the velocity function, and I'm going to put it over here. The velocity of the rocket with respect to time. So the velocity is simply the derivative of the position function. Now we can come over here and we can see that the derivative of this position function is going to be negative 32t plus 80. So negative 32t plus 80 is the velocity after t seconds. So this is that's part A. The next thing says, when does the rocket reach its highest point? Well, I don't really know when the rocket is going to reach its highest point, but I do know that the velocity when it reaches its highest point has to be 0. So we could take our velocity function here and we could set it equal to 0. We could set it equal to 0 and solve to find out what time it is when the object is going to reach its maximum height. So negative 32t is equal to negative 80. Divide both sides by negative 32 and you find out that t is equal to 2.5. So this rocket reaches its highest point when t is equal to 2.5. So 2.5 seconds into flight, the rocket reaches its highest point. So the next question up there says, what is the height of the rocket at its highest point? This is now a question about the position function. So this is a question about the position function. I know now that it reaches its highest point when time is equal to 2.5 seconds. So I can take the position function and I can plug in 2.5 seconds into the function and find out what that maximum height is. So we would plug that in, we would get negative 16 times 2.5 squared plus 80 times 2.5 plus 96, and we find out that that is equal to 196 feet. So in this case, when is the height of the rocket at its highest position? That's about the position function. So, and let me just clarify. When does the rocket reach its highest point was about the derivative. So this is when the derivative is equal to 0. When the velocity is equal to 0, it might be a better way to say that. When the velocity is equal to 0. So we solved for time. So the next question says, well, when does the rocket strike the ground? When does the rocket strike the ground? When does the rocket strike the ground is, well, how high is the rocket? What's the position of the rocket when it strikes the ground? So this is, again, when the position would be equal to 0, because there is no height. So I can come back to my position function, and I can say negative 16t squared plus 80t plus 96 is equal to 0. To make this a little bit easier, let's see if every term in here is going to have a g, every term in here is going to factor by 16. So I'm going to factor out a negative 16 in here. I'm left with t squared minus 5t minus 6 is equal to 0. That negative 16 divides off, and t squared minus 5t minus 6 factors into t minus 6t plus 1. So t, time, has to be equal to either 6 or negative 1 seconds. Well, we're not doing, our time has to be positive, so negative 1 is going to disappear because time has to be greater than 0. So in other words, this rocket strikes the ground at after 6 seconds. So that one was about the position function, because again, when does the rocket strike the ground? If we're thinking about height, well, the height would have to be 0. So at what velocity does the rocket strike the ground? This is now where we know that the velocity, we know that at time is equal to 6, the rocket is striking the ground. So we're going to evaluate the function at, we're going to evaluate the derivative, I mean to say, when time is equal to 6. So moving back down here, we're going to take the velocity function and evaluate it at 6 seconds. So that would be negative 32 times 6 plus 80. That would be negative 112. Or in other words, this rocket strikes the ground. It strikes the ground traveling with a velocity of negative 112 feet per second. Because remember, it's coming back down on the ground. So it can be negative because it had a positive velocity moving, going up, and it has a negative velocity coming down. So on what interval is the speed increasing? Well, this is more of a theoretical question. We know that, don't forget that speed, right? So speed is equal to the absolute value of the velocity. Okay, so we're really kind of asking, when is the absolute value of the function increasing? There's two ways to consider this. You could go look at a graph, and you could do that definitely to validate your answer. You could also look at this in terms of what we already know. We know that when time was equal to 2.5, we were at our max height. And then when time was equal to 6, we were at our, on the ground. So we hit the ground. So we have this really long time period, right, between 2.5 and 6 seconds. So the speed of the rocket was decreasing until it hit its highest point. And maybe I could sketch this for us. So if we launch a rocket off of our cliff, right, it's going to go up and then it's eventually going to come down. So as it initially left, the speed is decreasing until we get to this point where it reaches its maximum height. And then on its way down, although the velocity is going to be negative, remember speed is absolute value, so we are increasing our speed as we are coming back down. That occurs on the interval between 2.5 and 6 seconds. So the final question that we have up there then says, determine the acceleration of the rocket when the velocity is equal to 0. So acceleration is, remember that acceleration with respect to time is simply the derivative of velocity. And we want to know, what is acceleration when velocity was 0? So the last piece of this has to do with acceleration. And our velocity function was negative 32t plus 80. So acceleration has to be simply negative 32. So, and we can see that it is a constant. There is no variable in here. So when velocity is equal to 0, when the velocity is equal to 0, the acceleration is still going to be negative 32 feet per second squared is what it is. And that's actually the constant acceleration for gravity. So if you think about it, without any other forces on this rocket ship, gravity is always impacting everything that we do here on Earth, right? So it has a constant acceleration of negative 32 feet per second because it is also a vector, and so it was just coming back down as opposed to being shot up. It's now moving in a downward position, so we would have a acceleration of negative 32 feet per second squared.